This is problem number 14 for section 3.3. In this problem it says find the first and second derivatives of the function y equals x plus 5 times x squared minus 5x plus 25 over x cubed. Now there's multiple ways to solve this problem, and I'm going to show you probably two versions just to kind of give you a feel for what you can do with this algebraically to get it to essentially be able to take the derivative easily. The first thing I'm going to show you is that you can just use the straight quotient rule, but as you use the quotient rule, you also have to use the product rule because you have a product on top and then you have this quotient here. So we're going to have to use both. Let's go ahead and mark this up. That we're going to say the top function here is u, the bottom is v, and we're going to call this u. Then we're going to say, hopefully I'm giving myself enough room. I'm actually going to write this over here a little farther. So u prime, v prime. So u is x plus 5 times x squared minus 5x plus 25. V is x cubed. So v is the easy function. Take the derivative of that. That's 3x squared. This one, because it's a product, when I take its derivative, I got to use the product rule on this function. So this is where you kind of got to watch out with your u and u primes. You could label these different letters if you wanted. I'm just going to stick with u and v, and I'm just going to say that this is u and v here, and out here I'll just say u is x plus 5, u prime, v, and v prime. And so I've got u prime being 1, v is x squared minus 5x, that should say minus 5x plus 25. Derivative of this is 2x minus 5. Okay, so now I'm going to use the product rule right here, and I'm going to say that u prime v, so u prime, which is 1, so I end up with 1 times v, which is x squared minus 5x plus 25, and I'm going to add that with v prime, which is 2x minus 5, times u, which is x plus 5. Okay, now we have this set up over here. We can now use the quotient rule on this problem. So we're going to say dy over dx equals, we're going to start with u prime. U prime is this long piece right here, which we could simplify, and we're probably going to simplify in the problem. So we're going to end up with, this is x squared minus 5x plus 25 plus 2x minus 5 x plus 5. And this is all multiplied times our v, which is x cubed. And then I'm going to subtract v prime, which v prime is 3x squared, times the u, which is x plus 5, x squared minus 5x plus 25. And that's all over. We've got v squared. V squared would be x cubed squared. Now we've got a lot of simplifying to do here. So let's go ahead and start distributing and combining like terms. So this is x squared minus 5x plus 25. This will be plus 2x times x is 2x squared. 2x times 5 is 10x. Then we have negative 5 times x is negative 5x. Negative 5 times 5 is negative 25. And this is all times x cubed. On this side, we got a lot to distribute as well. The first thing I'm going to distribute is I'm going to distribute this. We're going to write negative, and then I'll have 3x squared. And I'm going to distribute x plus 5 times each of these. And I'm going to kind of do that down here because I'm just running out of room. So x times x squared, that's x cubed. X times negative 5x, that's negative 5x squared. X times 25, that's plus 25x. And 5 times x squared, that's plus 5x squared. And then 5 times negative 5x is negative 25x. And 5 times 25 is 125. Whew. And that's all over x to the 6th. Let's go ahead and distribute here on the top. So we end up with, well, we can combine some like terms. Maybe that's a better idea. Combine like terms, then distribute. So this is going to be, let's get the x squared together. It's 3x squared. This is minus 5x. That cancels with the 10x. We get 25 and negative 25 canceling. So we get 3x squared times x cubed here. And then we get minus, let's combine, we'll do 3x squared. And let's combine like terms here. This will be, let's see, x cubed minus 5x squared cancels with the 5x squared. Negative 25 cancels with the 25. And we're left with 125 here. And that's all over. Holy smokes, look at this thing cancel out. Let's work to the side now. So this is going to be 3x to the 6th, or 3x to the 5th. We distribute on this, and we're going to end up with negative 3x to the 5th. Negative 3x squared times this will be negative, that'd be what, 375? Yeah. Negative 375 x squared all over x to the 6th, which when we subtract these out, we get negative 375 x squared over x to the 6th. Cancel the x squared with the x to the 6th, and we end up with negative 375 over x to the 4th. So this is the derivative of y with respect to x using the quotient rule along with the product rule for this function here. Now at the end I'm going to show you what you could have done here. But before we do that, we need to get the second derivative done. Let's go ahead and do the second derivative. So that the d squared y over dx squared, so second derivative of y with respect to x. Let's write this as, I'm going to write this as equal to negative 375 x to the negative 4 real quick before I take the derivative. So when I do that, now I can just bring the power to the front. So negative 375 times negative 4. is 1,500, so I end up with 1,500. X to the, subtract 1 from -4, that's -5. So you could write that as 1,500 over x to the 5th if you'd like. That's the second derivative. Okay. What could you have done here to make this process maybe simpler? Well, what you could have done is you could have distributed out the top. And if you do that, you could get, so we're just going to take this is a could have done. So this is just after we found our answer, we're going to go back and we're going to say dy, we're going to say y equals, let's distribute, we get x cubed minus 5x squared, all right, distributing here, plus 25x plus 5x squared, when we multiply here, minus 25x plus 125 all over x cubed. And then you end up with combine like terms. This cancels here. This cancels here. And we're left with x cubed plus 125 over x cubed, which we can then split that. So x cubed over x cubed plus 125 over x cubed, which would be 1 plus 125 x to the -3 when we bring this to the top. Okay, so we could have simplified this entire function to this right here. And then imagine how easy that derivative would have been when we take the derivative of 1, that would cancel. When we take the derivative of this, we'd bring the -3 to the front and subtract 1, we end up with -375x to the 4th, and we get right to that in very few moves. So I guess what I'm saying is you're not going to always take the correct route, or the most efficient route, I should say. But knowing some algebra and how things can simplify and having better algebra skills can help you pick the most efficient routes more often. And the most efficient route for this problem would have actually been to just simplify it to start, so that when you're taking the derivatives, you're not having so much algebra to work through and sift through as you go throughout the problem.